Okay, what we are going to learn about is congruent, and in this case, congruent segments. Congruent segments are when you have line segments that have the same length. So over here you have a picture of two segments, segment AB and segment CD. And in the picture, if they want to show that they have the same length, what they do is they put a tick mark in between A and B. Just a little tick mark going up and down to indicate that these two lengths are the same. When lengths are equal, this is when they would say that AB equals CD. But for congruent, what they do is the symbol, they add a little something to it. They'll say that segment AB is congruent. Notice this is the symbol for congruent. It's an equal sign with a little wavy line above it. But segment AB is congruent to segment CD. So to represent that some segments are congruent, they make an equal sign with a little wavy line above it. Draw a big congruent sign right here. You see this a lot in geometry. That means congruent. And really, for the most part, when we're talking about segments, saying something is equal to and congruent is the same thing. Usually they use the equal to when you have actual numbers. Like if I know what the length of segment AB is, like it's 5. And they just use the congruent sign when you just want to talk about letters and just talk about the segments. Other thing they do is with the congruency versus equal, there is more of a difference when you get to two-dimensional shapes, because then it brings in not only segments but angles. But right now, congruent, equal, they're pretty much the same thing. One thing they sometimes do, if you have multiple segments in a picture, like if I drew AB here, you have that CD, MN, and QR. Notice here on MN and QR, I put 2 tick marks on there. That's representing that those two equal each other, but don't equal the other 2 segments. So the number of tick marks have to be the same. Now, things that create these congruent segments would be, the first one we're going to talk about is a midpoint. So, give me 1 second to move the board. A midpoint is a point that divides the segment in half to make 2 congruent segments. So we'll have a segment, say segment AB, and there will be a point in the middle. Usually it's M for midpoint, but it could be any letter. And it's saying here, M is the midpoint. An abbreviation of midpoint is MIDP. And so that means AM and MB are congruent. AM is congruent to segment MB. So midpoint, it divides the segment in half. It's just a point. There are many things that can create a midpoint. We call them bisectors. A bisector, it could be a point, it could be a ray, a line, a segment, a plane, but it's something that bisects, that intersects the segment at its midpoint. So for example, say we have this segment here, we'll just do 2 random letters, Q and R, and we have a line that goes through here. And this point where it intersects, it's still a midpoint. And it's still making that the segments QM and MR are congruent to each other. Let's call this line L. So line L is a bisector, and it made it so that segment QM is congruent to segment MR. So it could be a line like I drew here. It could just be a point like this example. They could do it with just a ray. I could take the arrow off on this end. I could take the arrows off of both of these and make it another segment. You could do it with a plane, but I don't have a picture of that up at the moment. I could draw one, but we don't usually see the plane very often. But it's just something that divides, bisects, notice the word bi is too, a segment in half. Examples of problems you're going to have to solve with this. Let's go to the next part. Okay, on this next part, they will give you some information and a drawing. On this first one, they give you this drawing of segment AC. B is the midpoint. You can tell because of the tick marks here and here. And they tell you, find the length of AC if AB is 10. Well, we'll put that in here. AB is 10. Well, if AB is 10 and B is a midpoint, that means BC is 10. So AC is 10 plus 10. It's 20. Very simple there. You just double it, add it together, it gets you the 20. On the next one, they'll tell you here that you have segment AB this time, and C is the midpoint. And it says that we're going to find AB if CB is 7. And this one is created by a line. Give you a second, try that problem. Okay, on this problem, you should see that AB would be 7 plus 7, 14. Because these two segments are the same. Now, one thing they could do, and I forgot to put an example of that up here. For example, I could give you a segment AB, put C as the midpoint, and I could tell you that AB is 12. And we want to find AC. Give it a chance, see if you can tell what AC would be. Well, on this one, what you would do to find AC, if AB, the whole length, is 12, you would take 12 divided by 2 to see AC is 6. So sometimes if they give you the whole length, you will divide it in half to find the two smaller parts. AC would be 6 and CB would be 6. So these are examples of some simple ones where you have these midpoints, these bisectors, creating two congruent segments. But we could add algebra to this, so let's try some algebra problems. On this problem, they do give you a picture. They show you in the picture of segment VW that M is the midpoint and VM is 4x minus 1 and MW is 3x plus 3. Well, on this problem, what you're going to do, these two segments, because M is the midpoint of the segment, VW, you have it that VM is congruent to MW. Those two segments are congruent because it says M is the midpoint. So in other words, 4x minus 1 equals 3x plus 3. This is a little different than segment addition postulate. This is where you're going to make two segments be equal to each other. You won't add them like segment addition postulate did. So that's our equation. We're then going to solve the equation. You're going to subtract 3x from both sides. You get 1x or x. Add 1 to both sides. X is 4. Now that we have x is 4, we can find the length of VM. The length of VM, well, VM is 4x minus 1. And we just found out that x is 4. So 4 times 4 minus 1, that is 17. VM is 17. A way to check your answer on this one, plug x into the other one, MW. 3 times 4 is 12, and 12 plus 3 is also 17. Both segments are 17, which is what you want. You want both segments to equal each other because M is the midpoint. And that does mean that VW, the whole length, is 17 plus 17. That is 34. So VW is 34. So this is doing a little algebra with this fact that you have midpoints. You're just making two segments equal each other, solving for x, and then plugging x into the segments. Way you can check is that on these ones, it should be that both of these equal the same number. Pause the video and see if you can try the last problem. Okay, on this last example here, what they did, they give you segment CR. A is the midpoint, and they tell you CA is 5x minus 7, and AR is 11x minus, 11 minus 2x. And in the directions, they say A is the midpoint, so these two segments equal each other. Find the length of CA and CR. Well, CA is congruent to AR, so 5x minus 7 equals 11 minus 2x. There's my equation to this problem. If we solve this, we can add 2x to both sides. 7x minus 7 equals 11. You would then add 7 to both sides. 7x equals 18. Oh, wait, did I make a mistake? Nope, this one is actually a decimal. I did not mean for you guys to have a decimal problem, but that's okay. If we do the decimal, 18 divided by 7, you get roughly 2.6. So on this problem, yeah, it's roughly at 2.6 for x. It will be estimates for the two other segments then. So if we try and find CA, with that one, 5 times 2.6 minus 7. You roughly get 6. You can check also AR. If you do 11 minus 2 times 2.6, you get like 5.8. Again, these are rough answers. They're close to being the same. I will tell you on any other thing, homework assignment, quiz, or test, it won't be a decimal. So they're both roughly about 6. And that means that CR then should be roughly 6 plus 6. It should be roughly 12. This is not the best example. It should be that they should equal the same thing, but we got decimals here. Decimals make it a little tricky. But there is the answer for this problem.